Can I do what?
You let Snoop on certain posts.
Yeah, so like YouTube is the website, and you can like scroll back and forth. It's really cool. Today we're going to do geometric terms. Okay, my EQ today were the key vocab words associated with geometry. I'm going to try and understand the basic terms of geometry. It's a very simple lesson today. Some key things are angle, circle, perpendicular line, parallel line, line segment, point, line, distance, and plane. Let's begin. Okay, a point. A point has no dimensions. A point is just a location on a plane, which is represented by a dot. Right? That is a point. Okay. It is, I guess, technically considered one dimension. It is really the key to geometry. There's a point. A plane is, it has two dimensions, and then it extends without end. Okay, and this is where our thinking kind of takes over as far as geometry is concerned. A plane, it says, is often represented by a parallelogram. So oftentimes when we talk about planes, you'll see them like this. Okay, because a plane goes beyond. It goes forever and ever. Amen. So a plane is what we'll be, we're going to be working in a plane for several weeks, pretty much the whole first half of the semester until we get to three-dimensional objects, okay? Everything we do, we're going to start off with lines and line segments, angles, shapes, so all like geometry, squares, circles, triangles, all of those are in planes, geometrically speaking, okay? And our principles of geometry are restricted to planes. They are only available to us in planes, okay? A line's one dimension. It's an infinite set of points represented by a line with two arrowheads that extends without end, okay? Let's see if we can get this. Infinite means what?
Non-stop.
Infinite means non-stop, but when it says infinite set of points, how many points are there? Yeah, and more than one, right? Okay. All we know is it's just a ton of points that are together. Okay, right? And what connects those points is called a line. A line would go from, I'll make it easier on you guys, okay? Let's say we have point A, correct? Right? Point A, point B. So far, the only thing I've got is two different points, okay? Then I can have point C. If I connect A, B, C, which is, you're about to find out, I'm probably the world's worst drawer, but that's great for geometry. Okay? If I connect those points, A, B, and C, put arrows on the outside of them, that indicates a line. Right? That's all we got to know right now. That's a line. And I could have an infinite number of points between A and C, and an infinite number of points beyond A and C. Yes, sir.
How do you know if it has more than one dimension?
So anytime I've got something more than a point, I'm going to have two dimensions. Okay? Anytime I have something more than a point. Okay? The point is just a single speck. It is representative of just a single aspect, if you will, of the plane. Okay? So when I start connecting points, that's when I'm adding dimensions. Right? Line segment is a cousin of a line. Okay? The only difference between a line segment and a line, I'll use the same example I just used. If I go A, B, C, but I do not extend beyond A or C. See that? Notice I don't have arrows, right? No arrows on a line segment. Got me? Okay. No arrows. It's still all the points between A and C. Line segment is 2 endpoints and all the points between them. Okay? If I start and stop at A and C, I collect all the points between them, right? But I do not go beyond it. So when I write line segment, I'm going to write it like that. Line segment is written with just a straight line on top of the letters. When I write a line, I'll write the points that I technically go through. Okay, I don't have to worry about B because it's between A and C. And I write a symbol that has arrows on both sides. And it looks like it's a really small thing right now, but it's really big. Huge deal to get my symbols correct. Okay, this is a line. This is a line segment. Okay. Anybody still need any of these definitions? Deal. The reason it's a big deal is because I also have a ray. A ray has one endpoint. Let's go A, B, C. Okay, check it out. If I went A, B, C, I'm telling you to start at A, go through point B, go to and through point C to infinity. Right? That is a ray. A, C. Right rays with only one arrow on top. So far, just to recap, we've got points, planes, lines, line segments, and rays. Points, planes, line segments, and rays. Right? Anybody have any questions about any of those, or what maybe is the difference between a line and a ray, a line segment and a line? Everybody good with it so far? Okay. You know, it's just detailed. So,
Well, I kind of need to know.
plane. Plane's probably the hardest one to conceptualize, but a plane is nearly it's when you add another dimension. This is what you were asking about earlier. When I add another dimension to a point, okay, I have a plane, right? But planes consist of an infinite number of points. Really all that it is, okay? And what happens is this, a plane, you're just adding a second dimension so it can go left and right, up and down, okay? And for now, for today, let's just stop with that, okay? For today, let's stop with that. Because we'll go beyond that, but and it's a really good question you're asking, but we'll get really to, you're going to see the differences between them way later in the semester. When we add a third dimension, you'll be able to see, okay, start with a point, and then I call this a triangle, right? And that's a two-dimensional figure. That's a plane, right? And then I add a height to it, it's called a prism. Okay? But that's a good question. And part of the class is maybe struggling and learning what a plane is. Okay? All right, let's go angle and vertex. An angle is a figure formed by two rays or sides with a common endpoint called the vertex. Plural is vertices. You can name an angle several ways: by its vertex, by a point on each ray and the vertex, or by a number. Right? So, I can get an angle with the most common way you're going to get it is 2 rays. Okay? 2 rays. Remember, here's a ray, correct? This is a ray. So if I started with A, let's just cut out the crap. Let's go A, B. Okay, I go A, B, because that's a big old point right there. Okay? And I go A, C. You see how I have 2 different rays here? I have ray AB, it goes this way. I have ray AC, that goes this way. What is common between those 2 rays? Point A, which we call the vertex. Okay? So the entire, check it out, guys. This entire, really this deal right here, what's between the rays is what we're going to call an angle. Okay? So this will be known as the angle. Right? That's going to be known as the angle. And this is called the vertex. But of course, as this bottom part of the definition indicates, okay, we've got to make it more complicated. Math. Right? So we have several different ways I can name this angle. Right? I can call this angle several different things. Here's one. I can call this angle BAC. Right? I can call it angle BAC. Start at the top, go to the vertex, go beyond. Okay? I can call it BAC. When you symbol an angle, y'all ever done the little gator symbol? See, this is why it gets real confusing here. Because last year this meant what? Less than? And now that means angle. Right? Angle BAC. That is angle BAC. Okay? We don't have inequalities in this class, so you don't have to worry about less than greater than. Right? You have to worry about less than greater than. Right? That's angle BAC. Yes, ma'am.
So when we're solving a problem like test, like for any class, how do we tell the difference between less than greater than or angle?
Most of the time when you see angle, it'll be the measure of angle BAC. Okay. And if you ever saw an inequality, you see it written as 5 less than. Right. But I'm about to really mess you up with something in there. So hold on to that. Okay. Another way I can name this angle, and the most common way that you'll get, let's just call it by the vertex. Let's just call it angle A. Okay. So you'll see this written as angle A. So good, right? Right. Angle BAC. Call it angle A. Okay. We could go the other way. I'm talking about angle CAB. Angle CAB. Yeah. Yeah. We're going to spell all sorts of stuff. Okay. You'll know more 3-letter words than you'll ever. Okay. All right. Everybody with me so far? Or this is where it can get really fun. Okay. I could just say, you know what, forget the letter thing. I'm going to put a 1 right there, and we're going to call this angle 1. Right? So I could call it angle BAC, angle A, angle CAB, angle 1. Any of them, right? We're going to practice that today. Okay? And if you have questions throughout the year, throughout this semester, please ask. because I kid you not, by the end of the year, we'll come back to this, like when we do our EOC review, okay? And the very notes you just took will be confusing to some people. Right? Right. Can you say that angle again? What do you mean? Very simple. Okay. This is what I tell everybody. The letter, you see the order of the letters? B, then A, then C. Take your finger, go from letter B to point A to point C. Whatever's in between there is that angle. Right? So, real quick, let's start with a point, one dimension. We talk about a plane, adding a second dimension. Inside planes, we're going to have lines, line segments, rays. When rays come together, they're going to form angles. Angles, the point that they come together is called a vertex. Good news for you guys. Last slide today. Okay, last slide. I want to go ahead and talk about it. We're going to be talking about them all year. Parallel lines. Lines that do not intersect and are coplanar. Coplanar. What does that mean, Tom? All right, coplanar. In the same plane. They share a plane. Okay? Coplanar means they're in the same plane. And this is where it can get really, really fun, geometry. All right? I've got a line here. I got a line here. Right? Here is how I will symbolize these lines are parallel. Ready? Like that. That means parallel lines. Parallel lines. Okay? Right? If I call this line A, and I call this line B, I could say this. Line A is parallel to line. Sometimes I write in cursive and print at the same time. Sorry, kids. Line B. You see how now they're parallel running straight up and down? Okay. So two vertical lines, that's how I represent parallel lines. When I write these out. Right? So if I saw, and they will simplify it too. We'll say A is parallel to B. All of that. All that good stuff. Parallel lines. Right? Perpendicular lines. Perpendicular lines are lines that intersect and they form right angles. Okay? So just because they crisscross doesn't make them perpendicular. Right? Because they crisscross does not make them perpendicular. What makes them perpendicular is when they crisscross and they form a right angle. So if this was line A, this was line B. By the way, I'll add my arrows here because I'll be very precise. Okay, those are lines A and B. If they form a right angle, you do this. Okay, form right angles. That's fine. Right? They are perpendicular. A, and the symbol for perpendicular looks like that right there, upside down, capital T. A is perpendicular to B. Any questions on parallel or perpendicular lines? Okay. All right. Well, I got good news. Good news is that we're done for today. Here's, I guess, the other part of the good news. I'd say 70 to 75% of what you need to know in this class we just covered. 70 to 75% of what you need to know in this class we just covered. Okay? Here is the tricky part. The class involves, well, what makes lines perpendicular? How do we get lines to be perpendicular? How can I know what lines are or are not perpendicular? How do I create perpendicular lines out of different types of shapes? Same thing with parallel lines. What makes lines parallel? What doesn't make lines parallel? What just tells me that lines are really close to parallel, but not quite parallel? What is the interplay between angles and when I connect those angles to form shapes? How do I take an angle and make it into a triangle after I connected it on 3 sides? How do I take lines and create shapes out of them that have geometric principles? Right? When I told y'all yesterday it was a hard class, this is what makes it hard. Okay? Is that the material is very detailed and meticulous. Right? Here's the substantive stuff. I will be mentioning angles and vertex and lines and line segments almost every day the rest of the year. Okay? Almost every day we'll be exploring this more and more and more. That's what this class is. Okay? So the good part is that we basically have the basics down now. Right? The other side of that, we got a long way to go